Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to solve this brilliant integral from 0 to pi over 2 arctan of sine of x over sine of x dx. Well, what do you think? Okay, as a first step, here we have sine of x, here also sine of x. Therefore, I am going to take a substitution. Sine of x is equal to u, then we should differentiate. So we know cosine of x dx is equal to du, then we can plug in. Now we should change the boundary. We know when x approaches to 0, u also approaches to 0. Upper boundary, when x approaches to pi over 2, sine of pi over 2, we know 1. So 0 to 1. Here arctan of sine of x, we know u over u, and dx we can isolate dx, we know du over cosine of x. So cosine of x, we know 1 square root of 1 minus sine square of x. So we have square root of 1 minus sine square of x, we know u square. Well, then we know definite integral independent of the variable. Therefore, I am going to change the variable. So now we can write here arctan of x times here 1 over x times square root of 1 minus x square times dx. Well, then here we have arctan of x. So I am going to take the series representation of arctan of x. We know the Taylor series of arctan of x. Here absolute value of x lower than 1, we have the series n is equal 0 to infinity minus 1 to the n power over 2n plus 1 times x to the 2n plus 1. So we can write now here integral from 0 to 1 arctan of x, we know infinite sum n is equal 0 to infinity minus 1 to the n power times x to the 2n plus 1 over 2n plus 1 times 1 over x times square root of 1 minus x square times dx. Okay, then now we know we can switch the integral sign and sigma notation. So here n is equal 0 to infinity minus 1 to the n power over 2n plus 1. Then here we have x to the 2n plus 1. Here we have x, so we know this x get cancelled. So we have integral from 0 to 1 x to the 2n power times, here we have square root of 1 minus x square. So we can write 1 minus x square raised to the minus 1 half power times dx. Okay, then to solve this integral, I am going to take another substitution. X square is equal to t, then we should differentiate 2 times x dx is equal to dt. Then we can plug in. So now we can write here infinite sum n is equal 0 to infinity minus 1 to the n power over 2n plus 1. Now integral limit we know also 0 to 1 x to the 2n x square we know t, so t to the n times 1 minus x square we know again t to the minus 1 half times dx we know dt over 2 sorry, here also we have x, so 2 times x. Now x we know here we can isolate the x, t to the 1 half, so here t to the 1 half. Okay, let us simplify. So here we know here 2 is a constant, so 1 half sum of n is equal 0 to infinity minus 1 to the n power over 2n plus 1 integral from 0 to 1. Now here we have t to the n here t to the 1 half, So we can simplify t to the n minus 1 half times 1 minus t to the minus 1 half dt. Okay, then let's recall the beta function. We know beta of AB is equal to integral from 0 to 1 x to the a minus 1 times 1 minus x to the b minus 1 dx. Now we have same type of integral, so we can represent this integral by beta function. So here n minus 1 half, here a minus 1, so n minus 1 half is equal to a minus 1, therefore a is equal to n plus 1 half, same as b minus 1 is equal to minus 1 half, so b is equal to 1 half. Therefore we can write here 1 half infinite sum n is equal 0 to infinity minus 1 to the n power over 2n plus 1 times beta of, now a we know n plus 1 half comma 1 half. Okay, then we know about the relation between beta function and gamma function. Beta of a b is equal to gamma of a gamma of b over gamma of a plus b. So we can write now here we have 2n plus 1. Now I'm going to take 2 as a common factor, so here we have 1 over 4 sum of n is equal 0 to infinity minus 1 to the n over n plus 1 half times beta of n plus 1 half comma 1 half, we know gamma of n plus 1 half times gamma of 1 half over gamma of n plus 1 half plus 1 half, we know n plus 1, gamma of n plus 1. Well, then we know gamma of 1 half, the value of gamma of 1 half is equal to square root of pi. So we can write here square root of pi over 4 infinite sum n is equal 0 to infinity. Now here we have gamma of n plus 1 half, so gamma of n plus 1 half, and here n plus 1 half, n plus 1 half times minus 1 to the n, here we have minus 1 to the n, and here gamma of n plus 1 we know n factorial. Then here again we can write now square root of 5 over 4 infinite sum n is equal 0 to infinity. Now in the denominator we have n plus 1 half, so I'm going to write n plus 1 half by using gamma function. Therefore if we take gamma of n plus 3 over 2, we can write this is also equal to gamma of 1 plus n plus 1 half, and we know this is equal to n plus 1 half times gamma of n plus 1 half. Now we can isolate the n plus 1 half, so n plus 1 half is equal to gamma of n plus 3 over 2 over gamma of n plus 1 half. Now here we have gamma of n plus 1 half, so gamma of n plus 1 half, and instead of n plus 1 half, instead of this n plus 1 half, we have gamma of n plus 3 over 2, gamma of n plus 3 over 2 over gamma of n plus 1 half. So we can write in the numerator gamma of n plus 1 half times, here we have minus 1 to the n over n factorial. Well, now I think you have a question, because why this n plus 1 half I converted as a gamma function, because now I am going to use this identity hypergeometric function In a previous video, we discussed about this identity we prove. So if you like to watch this video, I will add the link in the description and also make a card. So this is equal to series representation gamma of C over gamma of A gamma of B times infinite sum n is equal 0 to infinity gamma of n plus A gamma of n plus B over gamma of n plus C times C to the n over n factorial. Well, now I'm going to use this identity to solve our integral. So here we have now gamma of C, gamma of A, gamma of B. Therefore, here in our question, we have square root of pi over 4. Then before sigma notation, here we have this part. So here we have 1/2, 3 over 2. Therefore, I am going to multiply by gamma of 3 over 2 because here we have gamma of C. Now C we know 3 over 2 and also divided by A and B. Here A and B, we know A and B is equal to 1/2. So gamma of 1/2, gamma of 1/2. Now we know gamma of 3 over 2 is equal to square root of 5 over 2. So I'm going to multiply by 2 over square root of pi. And gamma of 1/2 we know square root of pi. Square root of pi times square root of pi we know pi. So I'm going to multiply by pi. Then here we have n is equal 0 to infinity gamma of n plus 1/2 times gamma of n plus 1/2 over gamma of n plus 3 over 2 times minus 1 to the n over n factorial. Okay, then we know here square root of pi get cancelled. These two also get cancelled. So now we have pi over 2 times gamma of 3 over 2, gamma of 1/2, gamma of 1/2 and this part. So we know this is equal to this hypergeometric function. So we have here 2f1 A. Now we know 1/2 comma again B we know 1/2, then semicolon. C we know 3 over 2 again semicolon. C we know minus 1. Okay, now this is the general representation, general hypergeometric representation of hyperbolic arc sine of 1. So we have pi over 2 arc hyperbolic arc sine of 1. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.